some of these are so easy that you might get confused, right? Do you guys remember graphing y equals -2? If I went y equals -2, and if you wanted to think of y equals mx plus b, that means that there is no slope, right? And it crosses at -2, so it would be a flat line at -2 on the y. Or if you wanted to think of it with the xy table, the only thing that this says, y equals -2, is the only thing that it wants you to do is to write your y value as being -2. So on the xy table, -2 for y, -2 for y, -2 for y, anything for x, because it doesn't even have an x. So you can put a 0, 1, 2, whatever. Anyways, we need to remember that when you graph y equals a number, that's a horizontal line. It's totally flat, right? So this guy crosses the y at -2, and it's a flat line. But before I draw my flat line, is this going to be a solid line or a dotted line? Solid, because this inequality has a solid line underneath it. So there's my solid line. Put arrows on it. So that was step 1 and 2. Step 3 is to decide what side your answers are on, the shading part. So my answers are either going to be all up here or all down here. So I either shade the top or shade the bottom. So let's test the point. The easiest point to test is 0, 0. So there's 0, 0. If I plug in a 0 for y and a 0 for x, now you might be thinking, wait a minute, there's no x. Exactly. Super easy, right? There's no x. You don't have to even worry about x. So this really says 0 is less than or equal to -2. Is that a true statement or false statement? False. So what does that tell you about this point right here? It doesn't work. So it's not a solution. So where are my solutions at? On the bottom. So all my answers are either up here or down here. So this did not work. So that didn't work. Put an X right through it. So my answers have to be on the other side. So I would shade in the bottom. And if you were to pick any point on the bottom, it will work. Okay, so that's how you determine how to shade. You pick a point, check if it works. If it works, you shade in that side. If it doesn't work, you shade in the other side. So if y equals a number is a flat line, totally horizontal, x equals a number would be totally vertical, right? So let me go to x equals 2. Here's 2. Let me put a dot right there. And normally, if it were x equals 2, I would just draw my vertical line. However, this is an inequality. It's not an equal sign. I needed to decide if it's a solid line or a dotted line. What do you guys say? Dotted, all right. So we're going to put a dotted line. Arrows on it. And now I need to shade in either the left side or the right side of this thing. So what do you guys say? If you check 0, 0, will it work? Yes or no? You guys awake?
No.
Too much Super Bowl partying? Yeah?
My mind is mentally depressed about that game.
Oh my gosh. It was a great game though. Wait a minute, I'm recording this. Sorry. So anyways, left or right side? Going to shade in the left or the right. What do you guys say? How about this? Easier question. Is 0 greater than 2? No, so that didn't work. So this point right here does not work. So where are your answers at? Where will the points be that work? On the right side, so you shade in this side. Okie dokie. Number 5. Again, another easy one that a lot of students get confused with. Think about y equals mx plus b. Where does it cross your y-axis? Where does it cross your y-axis? What's your m value? Your m value is -1. What's your b value? +0. If you want, put a +0 so you don't get confused. That means it's going to cross right here at 0. What do I do from that point? What's my slope? My slope is -1. So I'm going down 1 over 1. Down 1 over 1. So I'm going to keep putting dots right here as long as I want. And is this going to be a solid line or a dotted line? Dotted, because our inequality does not have a solid line underneath it. So I might as well go with the pattern. Now let me just put some other dots between the dots. There you go. Now we either need to shade in one side of this line or the other side of this line. If we check the point 0, 0 in this case, and it works. Well, it's like right on the line itself, so it doesn't tell you what side your answers are on. Or if it doesn't work, it doesn't tell you what side your answers are on. It's kind of like having a teeter-totter and you standing right in the middle, right? It's perfectly balanced. So you either need to pick a point that's on one side or the other side. You got to pick a point, right? So right here you can't pick 0, 0 because 0, 0 is right on the line. So give me any other coordinate, guys. 1, 1, okay. So 1, 1 is right here. And 1, 1 is clearly not on that line anymore. It's clearly on one side of that line. So let's check the point 1, comma 1. That means 1 for x, 1 for y. So here's y. I'm going to put a 1 right there. 1 is less than negative 1. So here's our statement. 1 is less than negative 1. What do you think? Is 1 less than negative 1? No, so that didn't work. So where are my answers at? The other side. So I shade in this other side. Any point on this shaded side will work. Okay. Number 6. If you think about y equals mx plus b, where does it cross the y-axis? Zero. So what do I do from that point? Up 2 over 1, 2, 3. Put a dot right there. Is this going to be a solid line or dotted? Solid, because it has a solid line underneath your inequality. So I want to keep going with the pattern, but backwards. And I want to do my solid line right through those 3 dots. Now once again, I either shade in this top part or this bottom part. And you need to determine that by testing a point. But obviously you're not going to test the point 0, 0 because it's not on either side. It's on the line itself. So you want to pick a different point. Now the coordinate that you pick, it's probably easier if you pick an x value of what? What's a nice x value to have right here? Because you have a 2/3. What's a nice x value to have? If you multiply by 1, you end up with 2/3. People don't like fractions. If you multiply by 2, what's a nice number to plug in right here? 3. So let's pick a coordinate that has 3 for x and whatever for y. All right, it could be 0 for y if you want. Okay, so let's pick this point, 3, 0. And if you go to the 3, 0, it's 1, 2, 3. It's right here and 0. That's the point right there. That's clearly below that red line. So let's test it. 3 for x and 0 for y. It's going to say 0 is greater than or equal to 2/3 times 3. And again, 2/3 times 3. The 3's cancel. So you really have 0 is greater than or equal to 2. What do you say? It doesn't work. The other side. So you shade in this top part. Okay, so I believe we have enough practice with inequalities to just graph one inequality. Now jump into systems. Just like a system of equation is more than one equation working together, a system of inequalities is more than one inequality working together. So back when we did systems of equations, we wanted to find the point that was in common, which was the intersection point. But right here, since we're talking about areas, we want to find the area that's in common. So we're talking about overlapping areas. Let's take a look at this top equation. And I want to graph this top one in red. So where does that cross the y-axis? 2. And what do I do from that point? Up 3? Down 3. 1, 2, 3 over 1, 2. Let's put a dot right there. And is this going to be a solid or dotted line? Dotted. Okay. And now I need to shade in either one side or the other side. Okay. So let's test the point 0, 0. Will it work? If I have 0 is less than negative 3/2 times 0 is just 0. So I'm going to end up with 2 because 0 plus 2 is 2. Is 0 less than 2? No, it's not, right? So we're going to shade in which side? The upper right, correct? Okay, so don't get too crazy with your shading, because what we're going to do is this other inequality on this same xy plane, and then we're going to really focus in on the overlap piece. So the other one crosses at -1, and from that point on to go up 2 over 1, and up 2 over 1, and is this going to be a solid line? Yes, it is. So you could do your solid line right through those dots. Wow, that's the most crooked line I've done. I'm sorry. Oh my gosh. Whatever, you guys get the idea. So anyways, we still need to shade either the left side of this blue line or the right side of this blue line. So let's test the point 0, 0 and see if it works. 0 for y, less than or equal to 2 times 0 is 0, so I'm just going to put the -1 right there. Is 0 less than or equal to -1? No, false. 0 is greater than any negative number. So this point right here does not work, which means I'm shading in the other side. So I want to shade in the other side. But you see, what really matters is the overlap piece. It gets kind of messy. So what I want to do is I want to switch colors. If you have different colored pens, it's awesome. And we're going to really focus in on the overlap piece. That's this solid line right here, and then this dotted line right here. And I want to do my, I guess, a dark shade of the double overlap piece. And this is my answer to this inequality, system of inequalities. Any coordinate that's in that green is the answer to that system of inequalities. One final thing I want to warn you about is if you multiply or divide by a negative on your last step, you have to flip that inequality symbol. Just look out for that. This, okay? And we do have a couple of minutes left on this video. Is there anyone that you guys would like to see done? Can't do all of them. 6? Sure. Okay, so 6, first you need to make sure that it's in slope-intercept form. Okay, so on the top equation, I want to do the top equation in red. I want to have to first get the y by itself, so go plus 3. So you're going to end up with y is less than negative 2/3 x plus 3. There's my red inequality. Might as well graph it right now. It crosses at 3. 1, 2, 3. From that point, I want to go down 2 over 1, 2, 3, and you end up right here. Is it going to be a solid or dotted line? Dotted. Okay. And the other one, I need to get y by itself. So this is a little weird because y is on the right side. So you're going to have to move things around. I want to subtract 4. Subtract 4. I'll have 6x take away 4 is greater than 2y. And then I'm going to get the y by itself by dividing by 2, dividing everything by 2. And I'll get 3x minus 2 is greater than y. And of course, let me flip it over. So I want to put the y on the left side and the 3x minus 2 on the right side. But check this out. It was opening up to the 3x minus 2, so it still has to open up to the 3x minus 2. See, this pointy piece of the inequality was facing the y. The pointy piece is still facing the y. So now they're both in slope-intercept form. Oh yeah, I forgot to shade on the red one, so let's go back and shade the red one. Let's test the point 0, 0, 0, 0 for the red one. Will it work? If I plug in a 0 for x and a 0 for y, it's going to say 0 is less than 3. Is that a true statement or false statement? True. So the red line, yes, all of this is working down here. So you shade in the bottom. Going for the blue one crosses at -2, and it goes up 3 over 1. And this one's going to be a dotted line also. And you're going to test the point 0, 0 again, which is clearly on the left side of this dotted blue line. So if you test 0 for y and 0 for x, you're going to end up with 0 is less than -2, and that's false. So you got to ignore the red and focus in on the blue. So this point did not work for the blue line, so your answers are on the other side of the blue line, so you would shade in this side over here. Now again, you have to go back and look at the overlap piece, and if you have a different colored pen, use that different colored pen. So you have a dotted side right here, a dotted side over here, and here's the overlap piece. So that's the correct answer for this system of inequalities.